This lecture is going to be pretty chill. We're just going to go through some random security topics and talk about a few little things, some attacks, some ways to avoid attacks. Since it's pretty chill and laid back, this is also only 30 minutes. Like, feel free to put questions in the chat if you think I can answer them in the lecture instead of putting them in the questions doc. This is going to be, yeah, super laid back. Okay, cool. Let's jump into it. I'm going to start with a couple demos. The first demo, I was just going to briefly mention what a DDoS attack is. So you may have heard this phrase from on the internet. You might have read news articles about, I don't know, some particular website was attacked by a DDoS. What that stands for is distributed denial of service. And what that really means is just that there's just a ton of computers asking a particular server for things at once. And the result is that legitimate users of the website cannot use the site properly. So I don't have an actual demo of DDoS, but you all demoed DDoS on the first day of our wonderful web lab class when you all visited Catbook at the exact same time and then everything started breaking. That is exactly what a DDoS attack is. Typically, it occurs more from like a bunch of computers that are controlled by a single person instead of like a coordinated attack by a bunch of random students, but that's the idea of DDoS. Okay, we're not actually going to talk anymore about that. I just wanted to mention that because I thought it was funny. Cool. The next thing we're going to jump into is another like entire category of attack on websites called cross-site scripting. And I'm going to start by just sort of demoing some cross-site scripting stuff. Can you do a DDoS through like an infinite while loop of get post? If your computer is fast enough to make all of the get posts, then yes. But it's pretty typical that most websites are going to rate limit individual users. So that's why the distributed word in DDoS becomes key, because it's pretty easy on your server to add limitations of be like, okay, if the same user is requesting again and again and again, let's stop them and ignore the requests. But if a bunch of different computers are doing it, it's really hard to tell which computers are legitimate users and which ones are like just fake bots. Yeah, Nick's also right. It's mostly an internet speed thing. Okay, we're gonna quickly demo something called cross-site scripting. So I'm gonna go to this wonderful URL right here where I put together something called Catbook Unsafe. What this basically is oh, let me zoom in here quickly. This is a really broken version of Catbook. So we're gonna log into this with my account. Okay, so we can post a new story. Everything works normal. Okay, so let me just copy something here. So the idea here is, let's say you're working with your team one day and you want to add some additional customization to your website. Let's say you want users to be able to post photos. Let's say you want users to be able to style the text on their posts. Let's say you want users to, do fancy stuff with their posts beyond just text. It's like a pretty standard idea, right? It makes a lot of sense. It would add a lot of functionality to users. So one way to implement that would be to just directly let your users write HTML code onto your site. That is basically where cross-site scripting comes into case. Yes, I do have a yellow lap. So in this version of Catbook, we've allowed cross-site scripting. And essentially what that means is that if I post something like this, just an image tag, some HTML, it's literally going to put that HTML in here and we end up with a picture of a penguin. That's pretty cool, right? Like I just added basically 2 lines of code, and for free, people are able to add pictures of penguins, pictures of Labradors, pictures of corgis, whatever they want to add. So that's tempting. Let me show you another quick demo of what you can do with this. Let's say I submit a style sheet instead of an image tag. And now, hopefully if Zoom animation aren't too slow, every time you reload this page, your page is now going to do a barrel roll because we added some keyframes like Claire showed you. Cool. So how exactly is this working? Okay. So React normally the way React works is it does something called escaping HTML. So that means whenever you hand React a tag in HTML tags, for example, script, style, image, any HTML tag whatsoever, it translates it into this gibberish looking stuff right here, which then the browser can translate back into the original thing. Okay, so this and LT colon semicolon is the same thing as a less than sign. That's why it's LT, and GT for greater than sign. So React does this for a very particular reason, because if React doesn't escape the HTML, if we do this thing right here that I've pictured on the top, then what happens is React sends just the regular old script tag to the browser. And then instead of rendering the word script like we did in the last one, let me just show that again. So in the last one, the browser ended up rendering the word script. But in this case, what ends up happening is the browser just reads that script tag as if it's an actual JavaScript script, and it just executes that code on your computer. So that's what you're seeing happening in this. I have bypassed React's XSS or cross-site scripting protections using this little chunk of code right on top here. You might see something interesting. It is literally called dangerously set inner HTML. And React calls it that because it is dangerous. Do not do it. It looks really ugly for a reason. It looks gross. The syntax is garbage. And the reason for that is so that it should stick out, and you should notice if you see this in your code base, and it should scare you. Basically, don't do this. If you do this, you will fail WebLab. We will fail you. There are not many things that can cause us to fail you, but this is very dangerous. Okay, so why exactly is this so dangerous? Well, once I have the ability to post something like an image tag or some style tags, what that means is that anything that anyone posts on here actually executes on my computer as code. So literally anything you post on here will execute on my computer. So if I send this to the chat, you all can go on here and then suddenly code that I as a user wrote, that little barrel roll code, is executing on your computers. You can probably imagine how with JavaScript code that could quickly become pretty dangerous. Like, for example, what if I wanted to write a Bitcoin miner in JavaScript and insert it onto Catbook? And then every time you guys open Catbook, suddenly your computer should start running my Bitcoin miner. Or a more pertinent example would be if I did something that stole your cookies. And we'll get into exactly how cookies work in a few minutes, but basically your site becomes extremely unsafe as soon as you do this. Okay. I added one more little demo about XSS because I thought it was really cool. So I added, you guys are all free to go on this as well and post interesting stuff, see what you can get to work. So I actually also added a little thing called the bio on here. It's pretty standard, you know, like Instagram, Facebook, they'll have bios. But once again, I left this bio vulnerable to cross-site scripting. So if I paste a little piece of code in here, in particular this one, I have this little click me, click me. Now I'm going to send you all this link. Okay. If all of you want to go in and click that link, okay, you should probably log into your Catbook first on this Catbook Unsafe. And if you click that link, and then you click the click me, and then you go back to your profile. Actually, let me just see if I can demo this. So I'm actually going to log in as a different user here. Oh, God. I go here, I log in as myself. Okay, I'm going to clear this bio here. So we're going to paste in this bio here. I'm going to click submit. So now MIT 6148 has that as their bio. Now, if I, over here on the right side as Kai, go to 6148's bio, and then I click this link, and then I go back to my own profile, suddenly my own profile has that link in it. Okay, how did that happen? Okay, I'm going to clear my bio again. I'm going to go back to this bio, click the link. So this is another example of what you can do with an XSS vulnerability. Once someone clicks a link on a website, you suddenly have full control to execute JavaScript code on their behalf. And I see someone in the chat is mentioning the MySpace bug. We can actually do one better, and we can do basically exactly the MySpace worm that you're probably talking about. So this is a clickless version of the same thing. So I'm going to clear my bio on the right side. You guys can also, I'll do this if you want to. Oh, geez, this barrel roll is really annoying. Okay, my bio on the right side is clear. It's empty. On the left side, I'm going to put this little bio right here. And then if I go to, on the right side, if I go to, as a regular user, I go to MIT 6148's bio, and then I go back to my own bio, suddenly Nick is also my profile picture. Okay, I'm gonna send this because I want you all to have Nick as your profile picture. So if you all go to log in to Catbook Unsafe and then you click this link, you will immediately have your bio set to this message. And anyone who goes to your bio in addition will also have their bio set as this message. Someone in the chat alluded to the fact that this actually was basically the same thing as a real worm that existed on MySpace a long time ago. And it's basically the same thing. As soon as you have a cross-site scripting vulnerability like this, things get really weird really fast, and people can do all sorts of weird stuff like that. Cool. Any questions about the XSS or cross-site scripting, the way this worm works? I can actually show you, if anyone's curious, the way this worm actually works. So the unsafe part of the code was this in particular, dangerously set inner HTML. Because what this does, again, is it bypasses React's protections where React strips out the tags, and it just directly puts the tags in there as HTML, which allows any user to basically run HTML code on any page that they can post to. In case anyone's curious, the way this worm works a little bit more specifically is there's an image tag here. So it turns out that this isn't entirely true. It's a slightly simplified picture. React actually still does strip out script tags, but it leaves image tags. And so what we can actually do, and what this exploit has done here, is we can take an image tag, we can give it a fake path. So we can say, okay, this is some image that doesn't actually exist. And then we can give it an on-error property. And that on-error property can literally just execute JavaScript. So I'm forcing this image to error because I'm giving it something that doesn't exist. And then I'm executing some JavaScript code. All this does is it says post to bio with my bio. And so that forces the person who visited's bio to become your bio. So that's how that worm works. Cool. I'm not seeing any questions on the chat anywhere or anything about this. So let's move on. So the next thing I was going to demonstrate quickly was something called a CSRF vulnerability. And the way this works is it essentially takes advantage of the fact that of how cookies work. So if you guys remember from the authentication and authorization lecture, I guess it was, what was it, earlier this week, Monday. Basically, once you log in to a website, instead of forcing you to send your password and authorize every single request you make to this website, what actually happens is that a cookie gets saved on your computer. And then once a cookie is saved on your computer, that gets sent with every single request that your computer makes, that your browser makes to that website. So in this case, in the case of a CSRF vulnerability, we're actually going to take advantage of that. What we're going to do, more specifically, is we're going to send someone a link that will make a request from their browser. And because it's coming from their browser, it's going to send their cookies. And Catbook is going to think that they're logged in as themselves when they make that request. So let me just demonstrate that. That might have been a little bit confusing as I explained it. What we're going to do is we're going to, and you guys should all feel free to log it to follow along with me on this. Feel free to go to the regular Catbook 2021. So this is the regular HTTPS and everything. It's not my unsafe version. This is a different exploit. You log into that. So I've just logged in. And then you click this wonderful little link that I have here. So once I go to that, you'll see it sits here for a second. And then it goes to Catbook. And suddenly I see a post from myself that says, "You have been pwned." Oh no. So if anyone was following along, I would also see yours. However, it turns out that this doesn't actually work in Google Chrome. So if any of you followed along in Google Chrome, then it's not going to work. If any of you followed along in Firefox, then it would work. So I know that Shannon uses Firefox because her name popped up here with the message, and probably anyone else who comes up here will also be someone who uses Firefox. Okay, so if anyone's curious how exactly this works, this is all that is sitting there on my the little link that I sent you. All that it does is it sets a hidden form and it posts to it, just like our code purposefully posts to /API/story. The attacker can also post to /API/story. But if you click a link, then you're allowing it to execute on your computer. This is why they always tell you never click on unsafe links in your emails, because you may open yourself up to a CSRF vulnerability. You can imagine that this is not so bad with Catbook, like if someone wants to post in your name, but you could probably imagine how with a bank or something similar, this could get really bad really quickly if someone could make a post request via your bank on your behalf. Okay, so how do we avoid CSRF attacks? Okay, so the first way is to use post requests for anything that modifies the server state or the database. Internet Explorer, I have no idea if it protects against this. The new Internet Explorer is Microsoft Edge, which is based on Chrome, which does because it's Chrome. Okay, yeah, sorry. Only use post requests for anything that modifies the server state. So the reason for this is that GET requests are really, really easy to do a CSRF vulnerability on, because literally an image tag or even like anything makes a GET request. It's really common to make legitimate GET requests, so browsers don't block GET requests as much. You can look into the details of that on MDN if you're curious. The other fix that's much more common is to utilize something called CSRF tokens. You don't need to understand this, but the gist of it is basically that a random secret value is sent from the server to the client when the user initially loads Catbook. And then the server on every request will verify that that token is in the request, that random value. And we can just ignore any requests that don't include that CSRF token, even if they have the actual cookies, because they must not be coming from Catbook, because only Catbook has the token. You can imagine that this isn't perfect because people can start trying to steal your CSRF tokens. I'm not sure what you mean, Vedanta, by that. The token is stored in a cookie. So if someone can steal your cookies, sorry, a CSRF token would not necessarily be stored in a cookie. That could just be something that could be part of React state. Yassine, yes, automating CSRF tokens is not something we expect you to implement for WebLab. It's fine if your websites are vulnerable to this. This is a very particular type of attack. But you're also correct in that there are lots of libraries that will handle this for you. So in reality, you wouldn't actually write code that does this. You would just follow some documentation, import a library that does this. And then the last thing I'm going to put on this slide is just use Google Chrome, because apparently Google Chrome fixed this a little while back by basically disallowing cross-origin form submissions. So what that means is the Google Chrome says, okay, this request came from kaiburchard.com. It didn't come from catbook2021.herokuapp.com, so I'm not going to submit the cookie. Seems pretty reasonable, right? Okay. Firefox still allows this, but they're working on it, so probably Firefox won't be vulnerable to this kind of attack soon. Yeah, Johan is right. There's an express middleware that you can use via a library that just adds the CSRF tokens. You'll have to do some configuration, but yeah. Taylor, in terms of services informing you that you've logged in on a new device, that can be useful to help prevent certain things, but it's not going to help against this because you're not actually logging in on a new device, right? In this kind of attack, the user is logged in on their computer and then they click a link. It doesn't actually log in on any new device because of that. It's their own computer that is causing the attack. All right, the next thing I wanted to show you guys briefly was HTTPS versus HTTP. So this program that I have up here is something called Wireshark. You may or may not have heard of it. Let me actually just share the Wireshark window because hopefully that's larger for people and they can actually see. Actually, I'm going to share my whole screen because I want you to see this as well. So if I get rid of the S on Catbook 2021, it will let me go to this unsecure version of it. And you can see that Firefox warns me that this connection is not secure with this little message here. I don't know if you guys can see that or not. It's a little bit small, but Firefox does warn me about it. I'm sure Chrome warns you about it as well. But what that essentially means is that HTTPS is turned off. I'm not going to go into the detail of how HTTPS works. I'm just going to explain to you what it does. So if I go to Wireshark, so what Wireshark does is it looks at the packets that are coming in and out of your computer. So at a very low level, it's looking at the traffic that your computer is doing. Now, sure, this is on, I'm running it on the same computer, but anyone who is on your network could run Wireshark and do the same thing. So for example, if you're at a coffee shop that is using unsecure Wi-Fi, anyone who is on that same like coffee shop's network would be able to see this kind of traffic, this kind of information. So I'm going to clear this and run it again. Now, if I then go and reload the unsecure Catbook, we're going to see a bunch of stuff come up here. That's all of the information going back and forth on Catbook. And now if I go and post in new story like this, we'll actually see a couple more things come up. And we'll actually see one right here, post/API/story. Okay, that seems interesting. So anyone from a coffee shop, remember, could see this if they were on the same network as you. And if we look carefully, I know it's a little bit garbled, but you can actually see in here, content labs are the best. Okay, so what does that actually mean in practice? What that means is that if you're on HTTP, not HTTPS, then anyone on the same network as you or an attacker who's somewhere else can see exactly what is coming between your website and the server. Okay, sure, in the case of Catbook, it doesn't really matter. However, you could probably imagine that on anything more important than that, maybe a credit card number, for example, if you saw a credit card number show up here, it would be pretty concerning. Couple lessons here. Do not use your bank's websites if they are not using HTTPS. Do not use your bank's websites on networks like coffee shops that you do not trust. But more importantly, you can just force your site to use HTTPS. That's the lesson to take away from here. Oh yeah, I guess I should show you what it looks like if I am using HTTPS. So if I filter just HTTPS traffic, you'll see that all of the traffic that's coming through here, and you can look on the right here, it's just complete garbage. It's completely garbled, and that's because it's encrypted. The HTTPS protocol will actually encrypt all of the traffic in between the server and the client. So anything else that shows up, if I do a post request on Catbook, I'm not going to find that text anywhere in here. Okay. Let's go back to the PowerPoint. And I'm almost out of time. I'll let you guys go in like 1 minute, but I did also have some stuff to go through about passwords. The TLDR here is that passwords are really hard to get right. So if you ever store your passwords on the server, then okay, we need to do sessions, we need to do cookies. Password storage is actually pretty complicated because you don't want to store the passwords in plain text on the server. The reason is because if anyone actually goes on your, anyone ever accidentally gets access to your server, for example, you all have access to the MongoDB instance that runs our Catbook. But because there's no password stored on there, you can't hack any of our users. If you followed all of the steps I outlined here, then even if passwords were stored on the server, then you still wouldn't be able to hack the users. But the TLDR here is it's okay if you're lost on passwords. You don't need to understand how passwords work because passwords are generally bad. This is what people use as their passwords usually. These are the most common passwords. They're terrible, people can guess them. And so the practical implication, the practical takeaway on security of passwords is we're just going to do npm install Google auth library like Johan showed you guys on Monday and let Google worry about all the password stuff because they put a lot of time into getting that stuff right that we don't have. Awesome. That's all I have for you guys on security. I hope you enjoyed these quick demos, and unless Shannon or Nick have announcements for today, that's it for today.
Come to office hours tonight if you need help. If you remember Alex Chen, who gave the sponsor lecture on games on Tuesday, he'll be there. So if you're building a game and need help, you should come tonight. I'm gonna pub our hackathon on Friday again. It's from 7 p.m. to 1 a.m. All of staff will be there, so all 12 of us, and we will be there to help you with your projects. This is a good time for you to get started on it and really get some good work done because the MVP is due next Tuesday. It is coming up very fast. But yes, that's all I have. Nick, do you have anything?
Nope, just come to office hours because we're lonely.
Two super quick things. If you have any other questions about security or that stuff, or I know I went through a bunch of stuff really fast, feel free to reach out if you have any questions about that. And then the other thing is subscribe to our YouTube channel, please. And watch all of our YouTube videos so that we can make some money. Thank you. See you all tomorrow.